Okay, welcome friends. Let's work on a couple examples. I'm going to start with another one from yesterday, somewhat similar, a little more basic one, just in case you need a little more review. So we've got two linear functions, and we want to graph them. So one on top, one on bottom, numerator, denominator. So the first step is to find your vertical asymptote. So we're going to focus on the denominator. And you know what we can do? We didn't talk about this yesterday, but if you factor, you should factor if you can. That can make it a little more easy to see. So I can pull a 3 out of both of those terms, and I can factor that. So now I can see right away the vertical asymptote is going to be when x is 2. So I'm going to go ahead and draw that dashed line right around 2. So I know there's a vertical asymptote there. In other words, x can't be 2, so it's a restriction in the domain. So that's why I put a dashed line there, because I can't ever let x be 2. And since x can't be 2, if you think about it, then there is no y value, so I can't graph anything with that little dashed line. But I can graph right around it, which we're going to look at. But next thing is before is the horizontal asymptote. Now that's the one where you make x go to infinity, and then you see what happens. So if you look at it, if you think of it this way, and at the very top, if you have x go to infinity, and then you add the 2, adding the 2 is really like minor, it's minuscule. We just kind of ignore it. Then at the bottom, you have 3 times infinity minus 2. Once again, the minus 2 we just ignore because it's so minor. But now you have an infinity on top and then 3 times infinity on the bottom, so the infinity is going to cross off. So you're going to end up with 1/3. So that's your horizontal asymptote, 1/3. It's right about there. So now we can start to graph it. So we just want a few points, a few key points, because we know the general shape of this graph. So let's start with the easy one. When x is 0, what's y? So when x is 0, it's going to be 0 plus 2, 3 times negative 2. So that's going to be 2 on top and negative 6 on the bottom, which is going to be negative 1/3. So that's going to be down here, right about there. That's going to be a point. So then right away I already know, basically, I'm pretty sure the graph is going to look like, I'm just going to sketch it and then erase it. It's going to look like this. Probably pretty much have to look like that. Let's just leave it up there as I guess, and let's verify that. I'm going to erase this part. Let's look at that point. You could pick a point way down here, or you could also pick a point way over here and see what happens. You want to try that one? Let's try that point. We didn't do that yesterday. Yesterday we always went to the vertical asymptote. Let's go to the horizontal asymptote. Let's put in when x is like negative 10. What happens to y? Then we avoid having to do all that fraction stuff. So if it's negative 10, it's going to be negative 10 plus 2 on top. It's going to be 3 times negative 10 minus 2. So that's going to be negative 8 on top. And the bottom I have negative 10, negative 2 is negative 12. 3 times negative 12 is going to be negative 36. And then you can reduce that. It's going to be a positive number. That's good. And I can reduce 4 goes into both. 4 goes into 8 twice. 4 goes into 36 ninths. 2 ninths. Very close to 1/3. It's almost 1/3. So it's right where we expected it to be, right there. It's good. It's on the positive side, but it's not all the way to 1/3. Because 3 ninths would be 1/3. And then if we wanted to be really good, we'd also check that other point right next to that x is 2 thing. So right now we have 2 points. So we could verify one more point. So we could say what happens when x is just a little bit to the right of 2, 1.99. So I put that in. It's going to be, on top it's going to be 1.99 plus 2, which is basically 4. And the bottom, and you can, really some of these you can just estimate it because you just want the approximate value. So I'm just going to estimate that to be 4. And then the bottom I have 3 times, and all I'm going to worry about here is it's a negative number, right? 3 times, because 1.99 minus 2, that's going to be negative 0.01. So in the bottom I have a negative number. I have a positive number on top and a negative 0.03 in the bottom. So that I know the final answer is going to be negative. And since I have a small fraction on the bottom and I'm dividing by it, it's going to make it bigger. So it's going to make it a big negative number, which is exactly what I wanted. So I know I have that point. So that was good. Now the other one is, as we know from these shapes, is going to be over here. And you could check a point or two, but I'm not going to do it for this video. So hopefully that helps make sense. And now do a harder one.